If an airport like Frankfurt Airport were forced to shut down for just one day, the losses would no longer be measured in millions but in billions of euros. So what happens when they have to build an entirely new terminal right in a place where operations cannot slow down for even a single minute? Terminal 3 is the answer to that nearly impossible challenge. A project spanning more than a decade, costing over €4 billion, built on the site of a former military base, squeezed between runways, rail lines, and an uninterrupted flow of passengers. There is no such thing as closing down to build, no room for trial and error. Everything has to be precise from the start. In this video, Quantivox Tech takes you inside a colossal piece of infrastructure capable of handling and operating hundreds of flights simultaneously in the heart of Europe. By the end of the 20th century, European aviation entered a clear paradox. Demand for air travel continued to rise while airport space was steadily running out. The global aviation industry fell into crisis with empty terminals and waves of canceled flights. Many airports were forced to scale back operations, but at Frankfurt Airport, Germany's largest airport, the trend unfolded differently. Even during periods of instability, passenger numbers continued to grow. By the 1990s, the airport's two existing terminals were already handling more than 54 million passengers a year, far beyond their original design capacity, and at a time when the aviation industry was under unprecedented pressure, Frankfurt chose to go against the tide by investing in Terminal 3, valued at around $4 billion. The project was not merely a response to immediate capacity constraints, but a strategic decision, a bet on the recovery of aviation and on Frankfurt's long-term role as a central hub in Europe's transport network. The scale of Terminal 3 is reflected not only in the size of the structure itself, but also in the way it is integrated into the airport's overall system. A nearly 6-kilometer-long Skyline line was built to directly connect Terminal 3 with the existing terminals. The journey from the airport's central area to the new terminal takes only about 8 minutes. The entire system operates fully automatically without drivers. Trains run every 2 minutes, reaching a maximum speed of 80 kilometers an hour. The Skyline station at Terminal 3 is approximately 150 meters long and 30 meters wide, with 2 platforms that allow trains to arrive and depart simultaneously. Outside the station is the public road network, followed by the twin tracks of the APM system, then an industrial service road, and furthest away the apron area. All of these zones are separated by fencing and controlled by independent security systems. When completed, Terminal 3 is expected to serve around 20 million passengers per year. The central terminal consists of 3 main buildings: Building 600, the main hall; Building 601, the security screening area; and Building 602, the commercial zone, designed with a forward-looking approach. From here, passengers move on to 3 piers, GH and J, which are capable of accommodating wide-body aircraft. The land to the south of Frankfurt Airport has served as a U.S. military base for several decades. When the Terminal 3 project was given the green light in 2015, the first task was not to build the terminal itself, but to deal with ground that had never been designed for large-scale civilian infrastructure. Within the first 6 months, the construction site was effectively turned upside down. Every day, 5,500 cubic meters of soil were excavated and transported away, equivalent to roughly 300 truckloads per day. The central foundation pit was rapidly dug to a depth of 5.5 meters, reaching close to the groundwater level, with a total volume of nearly 70,000 cubic meters, large enough to accommodate a future main hall with an area comparable to 9 football fields. To install the entire technical infrastructure below ground, construction teams continued excavating to a depth of 14 meters, under conditions of constant groundwater intrusion. Conventional construction methods were no longer viable. Professional divers were deployed to assist with pouring the concrete base slab underwater before the water was pumped out, treated, and returned to the surrounding soil environment. The foundation base was then cast with large-scale concrete pouring to create a stable footing for the entire structure above. Once the foundations were stabilized, the site moved into a decisive phase, constructing the load-bearing structure for the entire terminal. 3,000 of reinforced concrete columns were built simultaneously, forming a massive structural frame capable of supporting a terminal roof spanning hundreds of thousands of square meters above. At the same time, the main steel beams were installed using heavy lift cranes, following a sequence calculated with precise accuracy. This is not only the backbone of the building, but also a factor that will determine how the terminal operates for decades to come. From load-bearing capacity and vibration control to the integration of technical systems, internal transport, and the movement of tens of millions of passengers each year. From this point onward, Terminal 3 was no longer just a vast excavation pit. It began to take shape, like an airport city being assembled layer by layer right in the heart of Frankfurt. Once the main structural frame was completed, the site moved into the phase of enclosing the building and shaping the terminal's interior space. Large span roof structures were installed in sections, providing wide clear spans, while allowing natural light to enter the space below. At the same time, glass facades and steel structures were constructed in parallel, forming the protective envelope of the entire building. Inside the terminal core, technical systems began to be installed in parallel, including electrical networks, ventilation, air conditioning, high-capacity elevator systems for vertical circulation, and information technology infrastructure. At the same time, internal partitions and lightweight wall systems were constructed to organize operational spaces and passenger circulation flows. From this point onward, Terminal 3 gradually transitioned from a construction site into a complex operational system ready for high-intensity airport operations. In parallel with the construction of the terminal, the Skyline rail system was developed. As a key piece of infrastructure for Terminal 3, this APM line was designed to directly connect the new terminal with Frankfurt Airport's existing terminal system, ensuring fast passenger movement independent of surface traffic. The entire route runs on an elevated concrete guideway using two parallel tracks that allow continuous two-way operation. This system operates fully automatically without drivers at high frequency and with absolute precision, a mandatory requirement in an international airport environment with intense operational demand. As the infrastructure neared completion, Skyline was fully integrated into the terminal space, with seamless transfer points becoming the transport backbone that enables Terminal 3 to operate smoothly from day one. Building a structure is difficult. Building a massive structure in the middle of an operating airport is far more complex. For Terminal 3, logistics was not a separate work package but a challenge that permeated the entire project. Enormous volumes of materials were continuously delivered to the site: steel, concrete, precast components, and technical equipment. Much of this could not be installed immediately, requiring repeated relocation and temporary storage before reaching its final position. Despite the large construction area, space was constantly limited as every zone had to be shared between construction activities, internal site traffic, and airport operational safety. Ultimately, the success of this coordination rested on the workforce. With precise planning and tight coordination, the site was able to function smoothly. When it officially enters operation in 2026, Terminal 3 will handle an additional approximately 20 to 25 million passengers per year, significantly expanding the airport's capacity and reinforcing Frankfurt Airport's role as a major hub in Europe. This expansion at Frankfurt highlights how modern aviation hubs are scaling to meet global demand, but it still represents only one end of the spectrum when compared to the sheer land area and the scale of the world's largest airport, King Fahd International Airport, located northwest of the city of Dammam. King Fahd International Airport, covering more than 776 square kilometers, stretches across the deserts of eastern Saudi Arabia and is regarded as the largest airport in the world by land area, making it one of the aviation complexes with the greatest expansion potential on the planet. The airport entered commercial service in October 1999 and is currently operated by the Dammam Airports Company, serving more than 12 million passengers each year. From above, the facility appears like a metallic oasis in a sea of sand where aircraft line up to land under the blazing sunlight of the Middle East. Standing out within this vast layout are the two runways planned in parallel to ensure smooth and continuous takeoff and landing flows, while the terminal system is designed to serve commercial flights, business flights, and the operations of Saudi Aramco Aviation, the internal aviation division of the Saudi Aramco Oil Company. With its strategic position in the heart of the most important oil and industrial region in the Middle East, King Fahd serves as the air gateway for the entire eastern coast of Saudi Arabia, where every stream of passengers, cargo, and logistics must pass through. More than just an airport, it is part of Saudi Arabia's long-term infrastructure strategy, built to meet current needs while leaving room for growth for decades to come. King Fahd International Airport serves as the strategic air gateway for the entire eastern coast of Saudi Arabia, an area considered the industrial heart of the nation, where oil, petrochemicals, mining, and energy services are densely concentrated. Thanks to its location between the three key cities of Dammam, Dhahran, and Qatif. The airport connects directly to major industrial clusters such as Jubail Industrial City, Ras Al Khair, and King Salman Energy Park. Its proximity to these massive production centers means King Fahd is not only a passenger hub but also one of the most critical logistics links within the Dammam metropolitan area. One of the most notable developments is the Air Cargo Village, an on-airport logistics zone designed to handle hundreds of thousands of tons of cargo each year. Combined with the free zone being developed in parallel, international companies can establish light assembly lines, packaging operations, and distribution activities directly within the airport grounds without paying import duties. This model has already proven effective in Dubai and Doha, and is now being implemented by Saudi Arabia to enhance its regional competitiveness. Beyond air transport, King Fahd is also directly connected to the GCC railway network, an intergovernmental rail system under construction to link Saudi Arabia, Qatar, the UAE, Oman, and Kuwait. Once completed, this railway will allow goods from Jubail or Ras Al Khair to move straight to seaports and logistics hubs across the Gulf region, shortening transit times and significantly reducing logistics costs. Thanks to these multi-layered connections, King Fahd International Airport has grown far beyond the role of a conventional airport. It has become a strategic cargo hub where production, energy, logistics, and commerce intersect. This foundation is essential for Saudi Arabia as it accelerates non-oil economic growth and moves closer to its ambition of becoming one of the world's leading logistics centers by 2030. From the story of King Fahd International Airport, we can see a broader rule of modern aviation. An airport is not merely a place where aircraft take off and land, but a massive infrastructure ecosystem that connects transportation, industry, commerce, and energy. Whether built in harsh desert environments or densely populated cities, today's airports function as strategic junctions of the economy. They create global cargo flows, shorten transportation times, stimulate trade, and open economic opportunities that would have been hard to imagine just a few decades ago. For King Fahd, the combination of its geographic position, surrounding industrial systems, and new logistics projects has allowed the airport to go far beyond its traditional role, becoming part of the industrial energy commercial structure of the entire eastern province of Saudi Arabia. And on a wider scale, this is also the common development direction for 21st century airports, building stronger infrastructure, enhancing connectivity, and becoming drivers of non-oil growth, technological advancement, and global integration. If you've stayed with us this far, you may have realized that the world's greatest structures are not defined by their outward spectacle, but by how they operate, by the unseen systems that keep everything moving in perfect rhythm. And if you'd like to continue exploring the vast infrastructures quietly shaping the modern world, subscribe to Quantivox Tech. There are still many stories behind projects like these, and we will continue to open each door through a technical lens and with the highest level of authenticity.